Hi guys, as you can see today Katie is not with us, so I'm on my own today, so we'll keep the questions to our absolute minimum and we'll have a look at fuel pumps and especially common rail pumps, what we can test on the vehicles. So we'll get started. What we're going to look at today is it's a Delphi fuel pump. We're going to have a look at this one today. We'll have a look what's on it, and then we'll have a look what we can test. Yeah. So, okay. Now this is the Delphi fuel pump we're going to be looking at today. Obviously, I've got all pipes on it. We won't talk about them yet. First thing we're going to look at is high pressure pump, and it's a built-in low pressure pump as well on this particular pump. So it'll suck the fuel from the tank through the filter up to the pump, and then into the high pressure unit and make high pressure. Yeah, quite simple, just a pump. But look at this one here, the temperature sensor. Very interesting. We don't really look at these much, but always when you think you've got a fuel problem, first things to go wrong with any pump, a lot of mechanical stuff, when it starts getting faulty, it'll change temperature. So if you're looking at a vehicle that's got maybe a fuel problem, have a look at this through your scan tool. Temperature. Normally these things run, when they've been running, 30 to 45 degrees. But every time you go on your scan tool now, just have a look at fuel temperature, even if it's a good running car, so you can get some kind of idea of different cars and what the temperature they run at. A lot of the modern ones now recycle fuel. So out of the pump, into the filter, back round, and you're keeping that constant temperature, especially in Europe where it can be colder and things like that. That's why they're doing it, to recycle the fuel. If you ever see your fuel going up 60, 70, then you may be getting issues. So when you see that, even before a fault code, you know you might be getting issues on your fuel system. Right, let's get down to what can we test on this pump on the vehicle. So, have a look. First thing we have to do, we have to spin the fuel pump, constant RPM. So if you've got a non-starter, ideal is the starter motor. We're spinning about 300, 400 RPM. That's fine for a test. So we can actually test the pump when it's on the vehicle. There is a tool for it, it's this gauge with this adapter. Basically, we've got a rail pressure sensor. We screw it on the back of the pump, crank the vehicle over, and it'll tell us, to an independent of the engine gauge, what the fuel pressure is. Obviously, we haven't all got these gauges, and there is some drawbacks using these gauges, so let's have a look how we can do it a different way. First thing, when we're dealing with anything of this, we're going to be taking pipes off, we're going to take injector pipes off, things like that. You need some safety caps to stop any dust going in this fuel system, because then you will cause more problems. So we do a packet of them, all different sizes. Just send us an email to Tracy or one of the sales staff, and they'll get you a pack sent on. But them are very important, just to cover the caps, cover all the holes when you're working on these common rail systems. First thing, when we've got these pumps off and on the bench, when we test them, we take the suction control valve out. We do a lot of tests with the suction control valve because we're only testing the pump. That's quite interesting because we can crank this with the starter motor. If we put our blank in there, we can do a lot of tests on the vehicle. So using our suction control valve, let's see what we can test on this pump using what we've got on the vehicle. So we'll leave our suction control valve in, then we've got, let's get rid of that. We're going to go through a rail and then the injectors. So when we're doing these tests on the vehicles, what we have to take into account, the rail could leak out of the rail. Yeah. The injector is going to leak out of the leak off. That's all taking pressure away from the fuel pump. So if we know what should come out of these, and allow for that, then we can tell what the pump's working like. So we'll have a look at this. The first one, what's this rail off? It's I think it's a Ford Ranger one. When we have these set up, no wires go into them. This is an emergency relief valve. So if we've no wires going to them, it's an emergency relief valve. This valve should never open. If that valve's opening, the rail pressure should have exceeded the maximum, even on full revs or anything, and you're just cranking it over. So straight away, we'll put a clear line on there. Put a clear line on, and then we're watching what's coming out of here. Little point, these can leak very small amounts. So what we're going to look at with this is this much here. You might find you're cranking it over and it's actually filling inside this copper pipe. So what we're going to do, we're going to put a bit of oil in and make our own level before we start the test. So we know our level and then mark it on the outside with the biro. So if the diesel comes in there, just a small amount, you'll see your level rising. Yeah, there's just a little point because it's had me a few times on that one. Sometimes they'll whiz out, but if you make a mark up to there, then you can test that. We've done with that then. We want nothing out of it. If anything's coming out of that, it's faulty, you need a new rail, or we do send the valves for in the ends. If you've had contamination, you need to put a rail on, because that won't work on its own. Yeah, so we're good with the rail. On the other end of the rail, our rail pressure sensor, that's what we're going to be using today to read the actual rail pressure straight through our scan tool. So, get the injector next. We're going to leak out of the injector as well, which is going to take pressure away from the fuel pump. So yet again, we need to know what comes out of here. So I've done a few little tests on cranking with no start. Normally we'll be using some bottles like these. One word of warning about these bottles. There is so many imported Chinese ones. So I bought some and I've done some checking on them. They all read different amounts. So if they're slightly different and you've got this type of one, it's not too critical. We're looking for big changes in them. And all the ones that we sell, these kits, I've gone through them all myself, re-drilled every point, and we've recalibrated them all so they all flow the same. So if you get these kits from us, I think the whole kit's about $99. They've all been calibrated, they'll all flow the same amount. So anything you see different, you know it's right. So when we're doing this, we're not doing a test, because normally when we're doing this test and the engine's running, we're looking for maybe 10 mil of fuel over 1 minute going into these jars. And they've got measurements on the side of the jars. We're only cranking it over for 3 seconds. So anybody really, can you do a quick calculation? How much, because we'll be probably looking at about that much we're actually going to use over 3 seconds. So I did a quick test the other day, non-starting, I got 1 centimetre out of a good injector over about 3-4 seconds of cranking. Yeah, and you're looking for even. Every time you test these injectors, if one is high and the other ones are low, you'll have 3 good ones, 1 high one. If one of them is really low and all the others are all over the place, the lowest one is going to be the good one. It's never failed me that. I know one time it will, but they never decrease, they always increase. Yeah. So roughly, I would say 10 mil over 1 minute. You could even divide 10 mil over 1 minute, divide it by 60 times it by 3. If you're doing 3 seconds, and you'll get a calculation in YouTube. But about a centimetre we're looking for. If we're on 3, 4, 5 centimetres, there's something going wrong with the injector. We can't carry on with the test because the pump's making the pressure and wasting it all through the injectors. But when you've got to that stage, you've found that, you probably found your problem anyway. So let's have a look. So we know what this suction control valve does. Has a square wave go into it. Majority of the time, it's a 12 mil feed. A 12 volt feed. So it'll be 12 volt on, 12 volt off. And depending, this is a very important part, which way this solenoid's working will show you if you want more time on or more time off to make more rail pressure. The beauty of this pump here, I've already worked it out for you, the suction control valve makes full pressure when the wire is disconnected. Well, I picked the easiest one today. So, knowing this, if we take the wire off there, we have the injector with the pipe coming out of it, we have our rail, the tube out of it. We crank this vehicle over with the wire disconnected. What's it going to try and do? It's going to try and go to maximum rail pressure. What's maximum rail pressure? Well, we'll talk about a rough idea because they're all the same, and more later and later vehicles going higher and higher pressure. The normal ones that you see will be 1600 bar-ish. Can we achieve that on cranking? Yes, we can. On a lot of vehicles, they will achieve full rail pressure just on cranking. So these are making some serious pressure in these pumps. But yet again, do this test when there's nothing wrong with it. Just can get over, find out for your different vehicles what they're supposed to be. I know on a Ford Ranger 2010, crank this over, because the machine you can actually get for it is a couple of $1,000 as an emergency blow off at 1700, and you blow that off when you're cranking on just cranking it over, so you're probably doing 300-400 RPM on the engine when you're cranking over. So straight away now, this one disconnected. We're reading our fuel. We're reading our fuel on our rail. So if we get 300 bar, we've got that disconnected. A little bit comes out of this, none comes out of this. There's something wrong in here. Because when that disconnected, there's no control. So we'll want to be getting up 1200, 1400, 1600 on some systems. We'll want to be right up that end range. Yeah. So what happens if there's something with the suction control valve? The suction control valves are that cheap nowadays, but we have to be aware of Chinese copies because it's probably the most copied diesel part. So any parts you get off me, you know that they're genuine, they're the right things for the right pumps. Because I don't want to be going, I see them every day, these vehicles come in, I've had this fitted, that fitted, I'll take it off, put the genuine parts on, the vehicle's right again. So just watch them genuine parts, only put in these things. So if you've tested your pump, it spins round, bang, it makes 1600. You've changed your suction control valve, you probably sorted your problem out then. If the pump's making a lot less than 1600, 500, 600, and you're asking it for full fuel, then you know something wrong in here. Or possibly we've got a bit of air coming into the system causing it. And this is why we use these clear lines. We've got clear lines, we'll have one on the injector and one on this. Always use the clear lines. So if you see air bubbles coming out of here when you're doing the test on the injectors, stop, there's something wrong. Yeah? So where do we put our clear pipe? On any diesel, I see so many people putting it in between the filter and the fuel pump. Yeah, we can't do it no more. In the fuel tank, you've got a canister. Your fuel, it comes out of there, but watch the return, it goes straight into there as well. So if we get a little air leak in this pump, the front seal leaks, or something like that, one of these seals, this return line is going to be full of air, it's going to go into the tank on an old-fashioned one, it just drops into the tank and disperses. Now we've got these canisters to keep all the fuel in, it goes straight into the canister, aerates all the fuel in there, and your fuel feed picks it up and comes back. If you put your pipe in between the filter and the pump, you're going to think it's coming from the tank. All the time, filter, tank, you'll change all that. Put it on the return as well. If you see air coming out of the return, it could be from anywhere. Yeah. Hold it up like this. A big loop of pipe up, so the air keeps coming into here all the time. Yeah. What I find when we do this is that if it is coming out the pump and it's all aerating in here, then the feed line will start coming clear after a few seconds. But now you think about it, a few times we look at pipes on vehicles, and the pipes like this with loops. Yeah, I think we've all seen them in hydraulics or whatever. That's a non-return valve. Yeah. So if we get an air leak here, the fuel can't climb up to here and go back round. So that's really good because it's just working as a non-return valve. As long as that highest point of the system, the fuel can't come back down here. If it were laid down like this, the fuel will just leak back. So when you see these loops in these cars, like this, it's acting as a non-return valve. So quite interesting. I've seen a lot of people chop things out, put different pipes on, and then they get running problems and leaking problems. Ford Transit's a classic. It has them on both feed pipes, like that. Sorry, the feed and return pipe, like this. Right. So then this is a scenario we're doing. So the valve's knackered. We think the valve's knackered. So we put a new valve in it. Bang. Everything works again. We've worked it out. What can't we test using this system by taking the wire on and wire off? We can't check. We can check what it should go to. We know it's gone back down to 0. We know the highest point. All this in between, we're not checking with this. So if the pump, normally, if a pump can make maximum pressure, the pump's pretty good. So let's have a look at what we've got here. We've got a Chinese valve here. This was fitted, I think this lasted about a week. We're just going to have a quick look at it. This is a suction control valve. I think you've all fitted them to all different vehicles. This particular one you can strip down. Some of them are sealed on the end now, so you can't strip them down. What we find straight away, I know everyone can't see it, is screws on here. So circle it out at the end, pull this out. If you think you're getting a problem with this, and it is one of these ones, and just give this a polish. Just some polish or whatever on a rag, polish it until the screws that you can't see them no more. Yeah, just a light bit of oil on them. Put them back in, put the clip back in. Start it up and see if your problem's gone away. It's not going to disappear. So if you're getting the problem every minute of running, then suddenly you don't see it for an hour, and you know that this is what's causing it. Another little trick that I have tried, it works to a certain degree. The fuel smashes in against this, and it's one point of it all the time that gets seized. So if you want to do the Allen keys, and rotate it and put the tighten the Allen keys back up, then you put it on another point. The valve's getting warm from another point then, and that will show you a difference in its running. So it could possibly be not working properly, turn it round, and it'll start working properly for a bit. Only for a little bit, but it's a good diagnostic. You know that does that, and then it works when you turn it round. You can guarantee one side of this will be seized, and you've just pushed the fuel onto the other side of it, and it's just pushing the fuel in on a different angle, and it's making it work because it's not pressurizing that side all the time. Yeah. On these, we do all the different manufacturers on these ones. On the Denso ones, basically, all the cars, there's 3 valves that they use between them. And we have got a kit on special offer with all the 3 valves in. It'll do Holden, Toyota, Ford, and Toyota, Nissan. Anything making in Japan, these valves will cover it. So it's a good kit to have in your workshop. If you ever think you've got a little bit of a problem on this side, you can try one in. If it works all well, I'm going to sell it to the customer, but it might take a load of diagnostics out of it by just grabbing your valve out your box, putting it in, trying it. Always have to tell the computer it's a new valve. Interesting point. If a bit of wear happens in the system, yeah, and you put a new valve in, all the settings that the ECU knows, because every time this turns off, the ECU will take how many percent this was turned on for idle, and it'll start up again at that percentage. If you put a new valve in, you might not need anywhere near that percentage, or any change, new filters or anything, we need to tell the computer it's had a new valve or new filter, and then it alters the percentage, starts again from 0. So sometimes you might get these in, you just press reset, oh, it's working good. So that's just a quick point on that actual valve. Right, so we've got another scenario now. We'll crank this one over. Yeah, it makes 1600 pressure. Yeah, but we've got one of the injectors that's leaking a lot more, and it's bad starting. That's just proving that the pump works, and it works too well. But what will happen then, when you put your solenoid back in, it'll go to the 20% what it sees every time, and it won't start because this one's leaking, but the pump can actually do it. So I would suggest you just change your injector then you'll overcome it, and that percentage, you don't need to reset it, because with a new injector, it'll probably start up and run fine. When these valves are worn, sometimes the vehicles start and stop, reset, bang, it's starting every time, valve in again. So it's always that valve after you've done the first tests on the, see if we're hitting 1600. Very interesting point. My Dave, I've said where he works. So we'll just have a look at this one. Dave's saying, what happens if the valve works in the other way? We picked the easiest pump because we've only got 45 minutes to explain this. So what he's saying is, if the valve works power on, and when you look at this scale here, this is interesting. It'll go up to probably at 90% power on. If it's still not reached its rail pressure, that's when it's going to make a fault code up. That's where you get your fault code from. So these valves, the first 10% and the last 10%, them are fault code areas. So you imagine you've got an injector just overfueling. You've reset this, cranked it over, and one that needs power to the solenoid to work is 80, 90, 92%, and he's still trying, and the fuel's just leaking out of here. What will the ECU blame? He'll blame this thing here, or he might blame the rail pressure sensor. He's not going to blame an injector. Yeah, them are the two things that are making the rail pressure. Suction control valve is making it. The rail pressure sensor is reading it. He's going to blame one of them. Yep, I've never changed, I think I've changed, 3 rail pressure sensors in about the last 3 years. Very rare for them to go wrong, but always have to think about them, but they're very rare to go wrong. So when the ECU sees this rail pressure, keeps putting more and more voltage to it, still can't make it, he's going to blame this when it's this. Now we all understand, because he's putting more and more power to this, can't understand why it's not starting, he's going to blame the suction control valve when it's this. If you get air into the system, and we've seen it coming through, so you're getting air, fuel, still going to do the same. It's going to ramp up, go over that 90%, it's going to make a fault code again. There's nothing wrong with your system, there's some air in it. You might have a bad filter, you might have a bit of a leak somewhere. You might have just gone around the corner and been right on the last bit of fuel, and it's just sucked in. And then the customer might have gone to the fuel station, filled up, said, oh, this light's come on. There might be nothing wrong with it. So if he has been really low on fuel and these lights are coming on, might have just got a bit of air in it, just reset everything, go for a drive, see how it is. We're back to the one with the solenoid power to energize. Yeah, so it's totally backwards. So on this one, we just removed the wire, cranked it over, and we should have full rail pressure. So check what volt feed we're getting. I've got a little wire connector I put in here, and I just go onto the battery, get somebody to crank it over, And then when it's cranking over, I just put it on for a couple of seconds and I go full 12 volts. Yeah, I want to make 1600. We're doing exactly the same. We're not going to overload it and put it on for ages, but the solenoid doesn't really want to go there. He wants to work on and off, but then we can get our reading. So a wire to go in there. If anybody's got any old vehicles, nearly all the wiring off the four-wheel, all your four-wheel drives, if you put the outer casing off it, you're left with a plug on the inside and it fits into all these connectors. You'll find the same one nearly fits every single one, so you just run it out, maybe put a fuse on it, and then when somebody's cranking it over, just touch it onto your positive and negative, crank it, and then it should do exactly the same. A little funny one the other day, a guy said to me, and it was quite ingenious and I was quite happy to look at it. He says, oh, I've made a machine that does this. So what he was doing, he wanted to see if it would increase and decrease in fuel pressure, going one step further than this with a file. So what he was doing, he had his file set up on his battery and he was running his wire down his file. So your file's in and out, and a bit of what we'll call in English a bastard file, quite a rough file. He run his wire down it, and it made all these perfect. Every one was exactly the same. And then he went slower and quicker, and he could control his pump. Realised he could never get up to the top pressures. What he didn't realise was, one of these were hidden underneath. And it was leaking out of there. And when he did all these tests, then he came to it and found it. And then he realised everything he could do. So just with a file and a bit of ingenuity, he could actually see something happening mid-range in this rail pressure. So that was quite interesting for me to say you can do these things just with a bit of thought and actually check them out. So now I think we're all good. We turn this pump. It's a dead simple pump. And the only one we're looking at is this for up, down, everywhere. So if we get it, for instance, we'll pick on one vehicle. Let's pick on an easy one, a Colorado, the early Colorado 2008. So we can take the leak off the injector. It's got all these little fiddly clips. So we could actually just take it off the end and have all four running together, one little pipe coming out. We're just going to lick that little bit. A Colorado has a blow-off valve in, but rather than looking at this, it'll be stuck out about that far as 17 mil. It's exactly the same thing. If it's not got wires to it, and it's got a tube coming out of it, it'll have a valve in there, a blow-off valve. So you do that on that one, I'd go on a Colorado, I'd go all four. Or if you've got injectors under the rocker cover, just for quick basic testing, we can follow them round, find out where they come out, and we can test it there. But obviously, if we get a large reading from that, then we're taking the rocker cover off, we need to test it individually. But for a simple test, we can just, where they come out, divide your figure by 4 or 6, how many cylinders you've got, see if you've got what you're expected, and then you can move on. And then you can look at this and look at that and blame the pump. Very interested one on a Ford Rodeo that we had the other week. Couldn't do all this diagnostic. The Ford Ranger, it was a 3.2, so it was a later one. It's got electric pump in the tank, made rail pressure. I tested it 4 times this vehicle, making rail pressure, not making rail pressure. Oh, took this out, and I even put my blank in so I could do away with all this. Every time we got different readings. Be aware of this one. The gears fall off the front of them. So if we get a Land Rover, Ford Transit, Ford Ranger, and we're not making rail pressure, there's a little plastic inspection cover on the front. Take it off, just make sure your gear's not falling off. Because that one does your head in when you're trying to do all these tests, because you expect it to be turning equal amounts all the time. And if the wheels come loose, you're going to be hit and miss. If you do this test and where the metal's rough because it's been spinning on there, it grips onto it, you're going to say everything's good. So just a word of warning on that particular vehicle, we have to watch for this, the gears coming loose on the front. But plastic cover, remove it, look at your gear. If it looks slightly to the side, slowly just try that nut And it's left-hand thread, that nut, so we just need to try it. If it's loose, stop. You need to take the front of the timing cover off. Sometimes you have to replace the chain, the gear, and then obviously the pump. When you go to rebuild it, look at the torque figures. They are not correct in a lot of manuals. It gives something like 40 Newton meters. It's nowhere near tight enough. You put a new one on the day after, it'll come loose again. So check all them torque figures up with whatever program you use, but I think it's nearer 60 Newton meters than 40 Newton meters. And I only say that because I did it to the spec once and the wheel fell off the day after. So when I eventually looked round, I found out that the very early Ford literature tells you the wrong setting. Yeah, so just keep an eye on that one. Yeah, I might take one question. I know Katie's not here today. Sorry, read a bit. Down, yeah, oh, well, we'll take this one. I'm having a problem, and he's put these, I think I spoke to you last week about this, and I think we might have had a look at it. He's getting air in the pump. He's getting no air going into the pump, but air coming out of the pump with a misfire on the engine. Yeah. Right, so think of the scenarios. We've got, in the front of all these pumps is a seal. Yeah. It has to be on the low pressure side. It can't, no seal will hold the pressure of this back part. But if the seal goes, it will suck air in. It'll suck air in. This vehicle's got a misfire as well. It's very unusual to happen this, but I think what's happening on your particular vehicle, the injector is not sealing properly. And what it's doing, it's not sealing there on the end, and then it pushes compression up into the injector, and the actual air is coming through your injector pipes into your rail, and then back in here. And then this makes more pressure, pushes it all back again. And I think that's where you're getting it, because I've seen this when you've got contamination in some of these injectors, they can start doing things like this. One injector that we're just going to be really careful about, and we're going to speak about that next week a lot more, is this type of injector. So if anybody has had a look at these, when you get one that looks like this, be very careful with dust. Extremely careful after putting your caps on it. A set of these injectors for a 4-cylinder, or pick on a Hyundai I-Load, your costing is probably $2,000 for a set of injectors. If you get one bit of dust in this, the injectors will be destroyed on cranking. They seize that easy. So what we've been doing, we had a look at Glickle last year with this. So if you strip all these down after you've seized them, you can blow everything out. Sometimes you can get them working again. So imagine that's in your engine, you've done it, you've got air into it, it's caused a bit of dust into it, it's caused it to seize. And we take this off. If you ever get this scenario and it's on these type of injectors, before you start taking everything off, take that off. When we take this apart, we're going to blow all the parts off, we're going to clean them all off. Let's put 1600 bar, which is 25,000 PSI roughly, something like that stage, through the stuck injectors, and 9 times out of 10 you'll blow the little bit of dust or whatever you've got out through here, and then the injector will start working again. When we sell these injectors, nearly every time when I sell them to people, I say be very, very careful. Air, a bit of dust from the atmosphere, anything on these injectors will destroy them. And it will do it before you've actually started. Trying to tell the customer you've just fitted 4 new injectors and you need another 4, it's a nightmare. So on these ones, and we'll do a lot more on this next week, if I'm doing this test here, I disconnect the wire. I don't want any signals going into them, because if we put a signal into there, and quite a few of these ones, they'll put a little voltage to them while you're cranking over, which is really stupid, because what it'll do, it'll open the end of the injector. We've not got rail pressure up there yet. It puts a little voltage to them. That's open. All this compression with oily, dusty shit is going to blow right into these tiny holes, blow up into them, and cause the injector to stick again. Exactly the same scenario with dust anywhere. Yeah, next week we'll speak about how to bleed these and what I've had the most success with actually bleeding these. Yeah. So we'll do all that next week, but I'm just saying be very aware if you're doing any testing on the pumps with these, just keep them dust free as we can. Yeah, all you can do is the best you can do. Just have a look at a few figures, run through some figures. There's a lot of people ring me up and say, the rail pressure's wrong on idle. Have you got a fault code? No, I don't think it will be wrong. A lot of scan tools have it built in what the rail pressure should be and what the rail pressure is. A lot of them don't take into account how warm or cold the engine is. So we have a look here, like 300, that's an average rail pressure on idle with a warm engine. You could start the vehicle up, it can be 380, up near 380. Yeah, it's fine, there's not a problem with that. And when the vehicle warms up, the rail pressure will come down. It's acting like a choke or a bit more advanced for cold start or something like that. Some of these modern common rail now they go down to 240. A lot of the European ones do on, when they're warm, the pressure will go down to 240. We're not really, if it's in that ballpark, we're not really interested in the rail pressure. It's going to be right. What we're interested in, if it's on idle at 300 and no aircon's turned on or anything's moved with the vehicle, it should stay stable. 9 times out of 10, when you've got these suction control valves that are going faulty, you'll see this move. This 300, that's 300 bar. Look at your machine, see what you're reading in it. You might be reading 30, you might be reading 30,000, but it'll be just a different measurement that you're doing it in. So we're looking at 300 bar. If it was 300 bar on idle and then it jumped to 310, back down to 295, it's not bad. If it's going out of that range, so it's going 300, 340, 250, then you're probably looking at this suction control valve is sticking, where we had a look at it before. On this rod here, what's got seizure marks on it, it's probably just sticking now and again. Yeah, 9 times out of 10 with Nissans on that. The thing I get most is, we pulled over to answer our phone, we went to set off, and then this happened. Fault code, or the vehicle cut out with no fault code. What have you done when you're answering your phone? You've pulled over, you've left this, so imagine this, let's see how it's working. So this one would be power on. So when it's on idle, it's going to probably be at right at the one side. And when it revs up, it's going to be pushing it. So when we're sat on idle, we're just sat in exactly the same position. We're not moving with our revs all the time. We're just sat there. So if there's any seizure marks, they're going to catch when we're sat there. When you go to accelerate and it wants to move it, it's going to stick. Then it'll stall the vehicle or something. It's nothing to do with the phone. So there's not many occasions when you sit in a car on idle, traffic lights maybe if they're on for a couple of minutes, for 10 minutes, and then go to set off. So if they're at traffic lights and they've been there a long time, or they've had the phone, it's normally this valve that's sat in one position and then tried to move. Very similar to the one we did last week or the week before on the turbo vane. It wants to move all the time. It doesn't want to be sat in one position. So if there's anywhere on it, sit in one position will cause it to default the ECU and tell you there's pumps knackered, the rail pressure sensors broke or something like that. So 300. If it's jumping too far, we need to change the suction control valve. Yeah. Let's have a look at some at 1600. Our maximum we normally see on these systems If you're going to test it by pulling that plug off and it's one of these, you may get up near 1600. I definitely expect over 1200 for a good pump on cranking. Somewhere in that ballpark, so we can 2 minutes, pull all the wires off, crank it over, look what you've got. If it's reaching 1600, there's not much wrong with that pump. The valve, yeah, it could be, but not much wrong with the pump. We don't have to take it off and send it away to be tested, and then they say, well, there's not much wrong with it. 1 centimetre, that's what I roughly calculated when we're cranking it over for about 3 seconds, that it'll actually come up the pipe out of here. It's a tiny, tiny bit. It's about that far. Yeah, if one's going really far, you probably found your problem there. Yeah. 10 mil over 60 seconds. That's when we're testing all the injectors over a minute, when we've got it running and we're on normal rail pressure about 300. We're testing the injectors more then. Yeah. These on the Denso valves, so these valves, you can get the occasion. So if you ever fit one of these valves, I think the Ford Transit does a classic one, so it's a Denso brand, and you go to your rail pressure, it's no fault coating, but your rail pressure is up near 500-600, and it's no fault coating it. That's a bit strange because it's gone out that far. Why is it not reading it? Some computers aren't set to read rail pressure when it goes too high. Some of them, like the Bosch and the thingy, if they go out by 10 bar, they will put a fault code on. Some computers don't really read much on this. So that's why you could have a massive rail pressure fluctuation and the vehicle's running rough. But if the computer in your car's not set up to default, if it goes out of them parameters, you're looking through your data to see if you can find out what's wrong with it. If it's anything to do with a Japanese-made car, they don't really read that too much. So 10 mil, 60 seconds, that's across the board, that's the maximum you'd probably get. The later piezo style injectors will probably deliver a lot less. Don't worry if it goes less, only worry if it goes more. Like we said before, the lowest one is probably correct. Yeah. So that's about everything we've covered today. I'm sorry I couldn't answer 46 questions. I'm sorry I couldn't answer these today because hopefully Katie's back with us next week. These kits, they've all been calibrated. We've stopped getting from our user supplier. At first, these were about $400 for all this kit. So you can get these kits now off us, and they are made in China. I don't normally sell the products, but for the price of them, what I've gone through and calibrated them all, so they all deliver the same, the $99. So if you need one of them, it's got quite a few. It's got a lot of the Delphi connectors in, which wrap around the injectors. It's got the Denso ones in it, it's got the Bosch ones in there, and they're all calibrated ready. Today we've got an offer on as well on these caps. You need them caps, give the girls in the office a ring and they'll get a set side here. Brilliant when you're just doing these things, just to cover them up because you don't want any disasters. I believe they're doing an offer on the 3 most popular valves to keep in your workshop, and then nearly all the 4-wheel drives, the Japanese oriented one, will use one of these valves. The Toyota kit is actually an update kit. It's the latest one that Toyota are using with a big valve, so it keeps the solenoid works a lot harder and a lot quicker to try and stop this seizure on these small valves. So we've got all them in stock. If anybody wants anything, just give us a shout. Thanks a lot for watching. I'll see you next week with injector testing, and hopefully Katie will be back. No problem, guys. I'll speak to you next week.